Hi, how are you?
I'm fine. How are you doing?
I'm pretty good. How's the weather out today?
It's warm. I think it's going to get
That's
warmer.
great. That's great.
Okay.
Thank
Good afternoon, everyone. My name is Melanie Chaparian. I am a faculty member in the School of Liberal Arts and Sciences and a member of the President's Lecture Series Committee. We are extremely pleased to have Carolyn Abraham deliver the first lecture this academic year, a lecture that is intriguingly entitled, Every Genome Tells a Story. Do you want to know yours? Before I introduce Ms. Abraham, I'd like to welcome everyone in the audience today, those of you who are here in person, as well as those who are watching the live stream from the Lakeshore in Orangeville campus. An extra special welcome goes out to the students in Professor Darrell Culp's class, God, Science, and Religion, who are in our live audience today. I would also like to thank all those people whose work has made the President's Lecture Series possible. The PLS committee members, Angela Ojla, Jeff Bull, Chandra Hodgson, and our committee chair, Ian Gary. Humber's media service technicians, who you see working madly in the back behind the screen. The President's executive assistant and executive receptionist, Deborah Gray and Ashley Lombardo. And of course, Humber's president, Chris Whitaker, without whose support the series would not be possible. It's especially nice that President Whitaker was able to join us today. The PLS promises to be an engaging series again this year. In addition to Ms. Abraham's talk today, the following lectures are scheduled for this term. On Wednesday, November the 4th at 1 p.m., Queen's University history professor Dr. Ian McKay will deliver a lecture entitled Vimy Traps, Canadians and the Contested Memory of World War I. On Wednesday, November 25th at 12 noon, founder of the Policing Literacy Initiative, Jamil Giovanni, will present a talk called Bridging the Divide Between Police and Community. That lecture will be at the Lakeshore campus. If you'd like more information about these and other upcoming lectures, please visit the PLS website. It's worth noting as well that most of the previous PLS lectures are available for viewing there later on. Before I turn the floor over to Ms. Abraham, allow me to remind everyone to please silence all cell phones. If you have to leave early for a 12:40 class, please exit as quietly as possible. And most importantly, remember to jot down a question or two during the talk, as there will be time afterwards to answer some questions during the Q&A. Now let me introduce our speaker. After completing her studies in journalism at Carleton University, Carolyn Abraham worked as a crime reporter for the Ottawa Citizen, then transitioned to covering politics at Queen's Park, before becoming a medical reporter with the Globe and Mail, where she served as senior science writer for 14 years. In that role, she earned wide acclaim for her exploration of the ethical minefields in medicine, genetics, stem cells, the new science of race, the brain as sex organ, designer babies, and falling and rising sperm counts. Ms. Abraham's long time reporting on medical science has earned her 2 National Newspaper Awards, along with 4 awards from the Canadian Science Writers Association. It also led to her first book, Possessing Genius, The Bizarre Odyssey of Einstein's Brain. Ms. Abraham often appears on television discussing issues in science. She co-wrote the National Film Board's production, DNA and Dollars, and she was a presenter at Idea City. Her most recent book, The Juggler's Children, is a memoir that details her efforts to use DNA tests to solve the mysteries of her own family history. Both of her books were finalists for the Governor General's Award for Literary Nonfiction. We are very happy to have Ms. Abraham participate in our series today, so please do join me in welcoming her.
Thank you very much, Melanie. That was a real honor to hear you. I've researched all that and share all that, and it's an honor to be here. And I'm excited to do so, especially to talk about a subject that I think is going to have a profound impact on society in the years ahead, and I think we know this because it really already has. and that's human genomics. And there's a difference between genetics and genomics, and increasingly people are working hard to sort of split hairs about that definition. But where genetics sort of has come down to the study of heredity, genomics is more sort of the study of the function of genes overall and their interplay and how they work together to build and operate us. And I think we would be hard-pressed to think of a molecule in human nature, in nature period, that is in fact sort of more famous, if you will, than DNA. Because in the biological sense, in the purest form of what it is nothing short of the template for life. And you will see that even as far back as 1953, when Francis Crick, along with James Watson, had made the discovery of DNA, he wrote a letter to his 12-year-old son and said, "Oh, I think we've discovered something kind of important. It's the structure of DNA," and he called it the basic copying mechanism by which life comes by and from life. And I think since then, DNA, though, has become embedded in our collective psyches as something much more than that. First of all, I think that under the law, it is seen as a code, the ultimate form of identity in a way, that can identify us even hundreds of years after we've died. Put a name to old bones, distinguish one species from another. It has that much power in terms of putting a name to things. And then, of course, probably the first thing that embedded DNA into our collective consciousness was the use, as it has now become entrenched in our justice system, as a weapon to fight for truth. And it's, of course, being still wielded by humanity. It doesn't mean that, there's not error possible there, but we come to see DNA as something that can pinpoint the guilty and possibly exonerate the innocent. It's also become synonymous with culture. And by that I mean when we talk, for example, about corporate DNA, we're talking about the culture of an organization. We're talking about the way things work, what's done and what's not done. And we take that to mean, if it's entrenched, it's genetic, and therefore we refer to it as something as tangible as DNA is. And that's interesting because we also link it up, of course, with individual behavior. When we talk about a certain thing that someone may or may not do, we say or we predict or we assume that's just not in his DNA, that's not in her DNA. It has already transformed, jumped from science very much into sort of the lexicon of everyday language. And in the course of that, at the same time, it has also become the heart of many controversies. So whether genes should be owned and patented, whether they should be engineered, whether they should be built from scratch, from synthetic materials in the lab, and should life be manipulated to create designer babies or flowers that bloom on your birthday. All these kinds of questions that suddenly become possibilities because we have the ability to sequence, to unravel this code. So basically, there's virtually no discussion about human DNA that doesn't eventually lead to a hornet's nest of ethical, medical, legal, philosophical, and I would argue even metaphysical questions. Because Melanie mentioned my book, and I'm going to jump ahead here for 1 minute, because in the course of doing my book, I have two brothers and a sister, and I had one brother who didn't want to participate. And in the DNA testing, and we had a discussion about it. We were actually at a soccer fundraising dinner, and I said, "Well, why not?" And he said, "Well, what difference does it make what our DNA says about who we are?" And he said, "Do you really think that DNA represents who we are?" And I said, "No." I said, "I'm actually, not looking at it in that way." But he asked, "Is it the essence of us?" And I think that that's where DNA becomes a lightning rod for very deep and personal questions. And I think they're questions that we as a society and we as individuals really have to start asking ourselves in a concerted way, because we're going to run across the genomic era. It is here, it is coming, It is in your clinic if it isn't already, and later on I'll discuss a little bit more about that. But it touches on those issues of self-identity and privacy and discrimination, because the more science learns about DNA, the more we're coming to realize that actually what it is this really, it is the template for life, but it is this remarkable archive of past information about ourselves and our family histories, our ancestry as individuals and as the human species, the history of our species. But it's also something that will tell you about the present and something about the future. So how we deal with this staggering trove of information that's coming out of this is something that I explored in a recent project I did for the Globe and Mail. And I thought I would play this 5-minute video to sort of kickstart some of the issues that I wanted to speak about here. And I'm going to hit play, and it's going to work.
Think about the most personal information you possess. Is it your bank PIN code, your email password? Think again and consider your own genome. It's written in code in nearly every single cell of your body, and it is entirely unique to you.
The genome is massive in DNA content. There's 6 billion chemical letters of information. It's like a giant jigsaw puzzle.
Science has made huge leaps in putting that puzzle together. Just over a decade ago, mapping the first human genome cost $3 billion. Today, Steve Scher's lab can do it for $4,000. In a few weeks, he thinks it will be down to $1,000.
Personalized genomics or genomic medicine is starting as we speak.
Personalized medicine is the great goal of human genetics, the era when healthcare and treatments can be tailored to your genes. But to get there, if they can get there, they need more genomes to study, many more. Stephen Scher and his colleagues might want yours. They're launching a project in Canada like no other, the Canadian Personal Genome Project.
It's a big deal for us to announce this project because we've been working behind the scenes really in our spare time, certainly since 2007.
Back in 2006, the first Personal Genome Project began at Harvard. Volunteers agreed to have their DNA, personal traits, and medical records posted online on a database wide open to the public for researchers around the world to study. It's an altruistic gesture, but who else might use that information? The legal, ethical, and privacy considerations are unprecedented.
We are very clear that we cannot promise any kind of confidentiality or privacy in this project. One of the myths that the PGP is trying to dispel is that genomic data is actually private. I don't think it's possible to keep it private. We can say that there's certain risks. Re-identification would be one. Assuming that you consent to the whole project and you put your information online, you'll have some self-reported medical information that will be up, and that will be connected to your genome sequence. There'll be no name, there'll be no email address. There could be a picture if you consent to a picture, but that's not mandatory. Somebody could figure out who that individual was based on that information, theoretically. You could get an employer that could look at your disease risk profile and potentially discriminate against you. That wouldn't be consistent with Canadian law, but we don't have any genetic non-discrimination laws in Canada, so that would be up to the individual to then fight that in court.
Everyday Canadians are already facing a brave new world of decisions and outcomes based on knowing their genetic information.
When I switched jobs in 2010, I needed to disclose existing conditions. I was denied full disability coverage. I was only granted partial. Just because I have a genetic eye disease, it doesn't mean I should be discriminated against for all forms of disability coverage.
Hey guys. Huntington disease has been described as the most devastating disease known to man. It is a real definitive fate. If you get that test result, you can never give that back or not know that again.
When we sequence a genome in an individual that has a disease or a disorder, we have to compare it to something. One of the goals of the Personal Genome Project is initially to enroll what we call healthy individuals, and one of our earliest thoughts is we should probably sequence the genomes of the people who are going to be using the data on the front line.
It's exciting to be the first participant in the Canadian version of the Personal Genome Project. I hope and feel that the future of genomics will be such that everyone will have their whole genome data information available to them, where they can take it to their physician or their pharmacist, so that those professionals working with them can actually act on it in such a way that's individualized. Really, the future of genomics is personalizing medicine, helping us to get to the individual and treating the individual based on their DNA.
Within 5 years, it's quite likely that every individual will have their genome sequenced. Certainly everybody who is coming into the hospital, it's in the same way you might get an MRI, for example, or even have your medical health record taken. Right now, we can understand maybe 5% of what these genetic letters tell us. It's like a new language to us, so we have to learn that language.
Researchers have high hopes for what lies ahead, but no one knows if the benefits of this project will outweigh the social risks. Would you do it? If you thought the future of medicine might depend on it, would you bear your genetic secrets for science?
Okay, well, I wanted to finish off that video by just taking a quick poll by way of hands. So based on what you heard in that segment, and maybe what you already know about genetics and genetic medicine and the possibilities, how many of you here in this room would agree to have your genome sequenced? First of all, I guess I should ask, has anybody had their genome sequenced here or had any kind of genetic testing? Okay, one person. A whole genome sequence? Partial? And so how many of you here would be willing to do that kind of a thing or want to know? Okay, so quite a few. And how many of you would be willing to share that information, to make it public for the public good? Okay. A minority of people. So when we were doing this story at the Globe, a big conversation that would come up once we talked about all the risks, because the informed consent was longer than anything I'd seen for a clinical trial. It felt like it went on for about a dozen pages. The editor said, nobody's going to do this. Is anybody going to do this? And it's interesting because, well, the latest numbers, actually as of last week anyway, 800 Canadians have signed up. And they just did get new machines into the lab, and as was predicted, it's $1,000 now to do the whole genome. At the Broad Institute at Harvard and MIT, they can sequence a genome every 32 minutes. So you compare that with, you know, the first human genome map, which took 18 countries and $3 billion and many years. So things are moving quickly. So technology is basically outpacing our ability to deal with the data on so many levels. But I think there's a very interesting component to that, and that is the rise of technology is also shifting our definitions of privacy at the same time. I was speaking about this a little bit earlier with some of the student journalists about how, you know, younger generations who have grown up with rich social media networks because they're digital natives and are much more used to sharing what they did last night, where they were last night, who they were with, and taking selfies and, you know, sort of running their private lives in sort of very public and visual ways, might have fewer qualms about, you know, sharing genetic information. And the idea of open source technology is certainly, you know, growing into a very strong culture online in the science world. But this is all very exciting stuff that we can do this also very quickly. But the trouble is that one thing that hasn't kept pace with that is that scientists are still very much lagging behind the ability to interpret DNA. They're sort of at the see, dick, run stage. And if they're at that stage, it means that while they're getting better and better at pinpointing variants and mutations in genetic code, there's still very much, it's still very much a work in progress in determining what those mutations actually mean. So, and because of that, I think that there's a sense, because we have the ability to take the test, we should have the ability to understand the results. And there is a massive gap right now, I think, in the public mind around what genetics is and expectations and how far we are from actually meeting those. So to put it bluntly, as I mentioned, DNA is this great molecule that's, you know, a treasure trove of information about your past and your present and something about your future, but it is not a crystal ball. And very, very few straight lines can be drawn between a gene and a trait. So you might have a high risk for something or a low risk for something, but you know, not even eye color or height can be predicted by simply looking at a single gene. So there are, of course, some notable exceptions to that. Referenced in the video was Huntington's disease or cystic fibrosis, where, you know, these genes have been very well identified and very well studied, and they're known as single gene disease disorders. The other thing that it's already proving very useful for are genes that will be able to tell you whether or not you're a fast metabolizer or a slow metabolizer of drugs. And so you should know what kind of drugs that you should take. And there also have been great success stories, people with extremely sort of mysterious disorders that have, you know, lived with terrible symptoms through their lives because they have these, you know, conditions that have confounded doctors, and now suddenly, after all these years, they can pinpoint the gene that's malfunctioning, and in some cases have been able to come up with a treatment to make their lives livable. So that's all good news, but the truth is that the genetic story behind sort of the big killers in our world, the cancers, the heart disease, the diabetes, that are likely to involve, you know, many, many genes, and also a very sort of nuanced interplay that, you know, they're still trying to suss out between the way that we live and how our environment and our behavior shapes or influences the way our genes work, is still a picture that's yet to emerge. So one of the first things I think people might find when they look into their DNA is actually how much you won't learn from looking into your DNA. There will be sort of a long list of traits and things that will have percentages attached to them, trying to estimate your risk relative to the general population. And you know, so what kinds of things might you be able to learn? Well, you know, for sure you'll know whether or not you have a gene that determines whether you have wet or dry earwax, say, or whether you have the gene that allows you to smell asparagus pea. Not that you would need a genetic test for that, but you just have that kind of confirmation. But the point is that most things are a maybe, and they're calculated in terms of probable risks. And you know, for many people, that's probably okay. There are probably people out there who would rather have half the picture than none of the picture. You know, they are content to live or with the ambiguity and the uncertainty. And as Jill Davies is the first Canadian who was in the project, you know, she's comfortable with that ambiguity. She is a genetic counselor, but she also is very keen to do something, as others are, if they think it might help conditions that they might be at high risk for. Craig Venter, for example, who I don't know if that name means anything to people here, but he was the scientist who led sort of the first private effort to map the human genome, and then it turned out that the genome that he mapped was his own, and he learned early on that he was probably at high risk for melanoma, and became very active at checking his body and so on, and looking for marks that might suggest, you know, that they could be cancerous, and actually did because of that have a mole removed, and you know, it's a very aggressive cancer, and you know, credits, you know, the fact that he had that information to inform the way that he took care of his own health. But as we all know, living with uncertainty is not for everybody. It could create what has come to be known as the whole class of the worried well. You know, people who walk around with a certain amount of anxiety and stress about getting conditions they might never get, or stressing the healthcare system and looking for treatments to treat conditions they don't have with treatments they don't need. And there have been studies done on that in the United States, but in Canada it's been a little bit different because we have a publicly funded healthcare system. These things so far have been a bit harder to track. And then of course too, there's the other possibility. People who will automatically take what they see and treat genetic information, as society tends to do, with a certain amount of with a sense, basically, that genes are destiny, that there's nothing that they can do about what they see in their DNA. And you know, this idea that risk is a guarantee, or the whole notion of genetic determinism, it really is completely illogical at this point. Because as Steve Scher noted in that video clip, more than 90% of the human genome has yet to be understood. So I always think of it in terms of, you know, a canvas or a work of art, where at this moment, you know, we're sort of peeling away the cover of the canvas and we might see a few square inches of blue. And you look at it and you think, oh, that must be the sky. And yet it might well be the ocean. We just don't know. Or you might have a gene that predisposes you for something, but there's a gene, you know, further down the stretch of your DNA that might offset that effect. So it's still very much a work in progress. And you know, that sense of uncertainty I came to understand in pretty dramatic fashion myself back in 2003, because I was pregnant with my first child, and I had taken part in a genetic study that was sort of doing a karyotyping test. So that's a snapshot, which you saw there, pictures of my chromosomes, as part of a study that was going on in Toronto. And the results came back, and I got a phone call to come in to hear the results. And you know, I immediately panicked because nobody calls you in to tell you good news. And I got there, and of course it didn't help matters that this was in the middle of the SARS outbreak in Toronto, and I come into a room full of doctors wearing, and genetic counselors all wearing masks, and everybody sounded like Darth Vader. And they told me that what they saw in my test was that I had this inversion, they called it, that part of my chromosome 11, so one of the 23 pairs I had inherited from my parents, was upside down. You know, and this is immediately sort of shocking news, I think. And you know, so I immediately say, what do you mean? Do they mean inverted, you know, upside down? And I'm thinking upside down like a bat, or like a Led Zeppelin song, you know, you play it backwards, it says something awful. You know, what do we mean when we say inverted? And they said, well, we don't know, but you know, and of course I went and looked this up like crazy on the internet by myself, that you know, chromosome 11 is a big chromosome, a lot of genes involved in brain function. But the point was they couldn't tell me what it meant, but they did suggest that it could lead to genetic instabilities, and did I want to test my unborn child? So I went away thinking, okay, well, you know, maybe I should, maybe it's the responsible thing to do. But on the other hand, like, maybe this is why I'm really terrible at remembering names, but I'm really good at remembering phone numbers. You know, who knows what this means? But at the end of the day, I decided that, you know, I was walking around with this upside down 11, and, you know, so far so good. So I think I would just wait and live with it. And a short while later, it wasn't that actually, I would say about a year later, I happened to be at a structural variation, a genomic structural variation conference, which might sound actually very dry, but it actually was not. These guys actually know how to have a good time. There was actually like a beer bar up at the stage. And they got up and they had now started to amass, because the cost of decoding DNA had started to fall, and they had begun to amass you know, great numbers of genomes. And what they were finding was that they didn't know what normal looked like. There were all kinds of people walking around with half their chromosomes hanging upside down like bats, and quirks and missing stretches of code. And also what came out shortly after that, which really was a huge revolution, or it certainly upended about 150 years of science, was this idea that we are a 50-50 split of our mothers and fathers, right? We've all, since Mendel, grown up thinking that we're half mom, half dad. Even though, you know, intuitively you might have a sibling, you go, no. You know, this sibling is all mom or all dad or what have you. And now it turns out that there may actually be a genetic basis for this, because there are, in fact, many cases, it's not unusual to find that a person has inherited more than one copy, but 2 or 3 or several copies of one gene from one parent, and no copies of that gene from another parent. So it's actually, it doesn't break down in that nice, tidy, clean way that we had assumed that it does. So I just point out that if we are still at the stage where we are understanding what's normal, and that the range of normal is as wide as it is, there's a long way to go in understanding how, given the dynamic lifestyles and diversity of our species, why that would be the case. And there's something I think kind of gratifying about that on a philosophical level, because let me just go through to this picture, which I think sums it up. When the first human genome maps came out, there was this wonderful harmonious message that said, okay, like we're 99.9% identical. We're all, we're all so closely related that just, hardly a hair of code, as I like to think of it, separates Dolly Parton from the Dalai Lama. So, that was exciting, and that was one of the big surprises and sort of happy messages that was put forward, except that in very short order they realized that that wasn't the case, and that number had been slightly overestimated. So maybe we were 98% identical, or maybe it was like, 98.5%. But what you quickly realize when you do the math, when you're talking about a code that's 3 billion chemical units long, even a 1% difference is massive, right? And so it's why it can give rise to the difference between a gene that might make you die of sudden cardiac arrest at a very young age, or why somebody has curly hair, or why we can give rise to this wonderful pantheon that is humanity with somebody like the Dalai Lama and Dolly Parton and Donald Trump for that matter. Because, on the biological level, what DNA is, it's the instructions to build and operate you. And it's written in this living language. And it responds to changes in your environment. And so there, as a result of that, it is really only one side of your story. And at this point, that story is a little bit incomplete because science has a lot of work to do to understand the language in which it's written. But in the meantime, and certainly I wouldn't say in the short term, there's also a wide range of entities and people who are very keen to know what your story says. So we've talked a little bit about science and why science wants it, for obvious reasons, to better understand genetics and to be able to sort of craft the kind of basic research that will lead to the treatments of the future. And why doctors want it, so medicine. So doctors are interested in it already, and for many clinicians, this is a difficult time because in many cases, people have already gone out and begun to do direct-to-consumer testing. They're coming in with results. They want their doctor to help them interpret what they're finding out. And genetic science has evolved so quickly that it's hard to keep pace with what's known and what's understood. So doctors want to do it so that they can diagnose with better precision and treat you with better precision. But I think what's going to happen at the same time to sort of speed that process up is that there's going to be an economic imperative for the healthcare system to embrace genomic testing. So I'll give you an example of this. Just on the fundamental level, the bottom line is it's going to become cheaper to decode the whole of you than it is to go on a fishing expedition and look for things gene by gene to find out what might be wrong. So there's already studies up and running in Canadian hospitals and trying this out. What will happen if somebody comes in with something that's not clear to us? We'll do their whole sequence and we'll look at all their variants. And one example of this is, this is a few years old now, but still very relevant, is, it wasn't that long ago in Ontario, for example, that the healthcare system was willing to pay for women who had a family history of breast cancer to go out and have mastectomies at about $20,000 a shot. Yet they had no idea whether or not they actually had the gene that would have given them that elevated risk, that gene type that would have given them that elevated risk. So that genetic test is about $3,000 or so. Now, granted, it doesn't account for all of breast cancer cases. In fact, a very slim minority of them. But still, we're operating in the dark, and the economic case just simply doesn't make sense anymore. So there's the sense now that you can just go ahead and sequence the whole genome. But the problem is with that is that a lot of other information falls out of that closet when you open the door completely. So this is something that, medicine calls incidental findings. So somebody comes in, you're looking for one thing, but you end up finding something else. I was recently talking to researchers at one hospital who talked to me about the case of a child who came in with a mysterious genetic disorder. That's what they felt it was, and they did a whole sequence of both parents. And in the course of sequencing the parents, they discovered that the mother had mutations for the breast cancer gene. So the parents weren't even their patients. But now what do? Do you tell? Do you not tell? Is this medically actionable? Because that's sort of where the guideline is at right now, is that if doctors accidentally, inadvertently find something that could, represent a serious health condition that is medically actionable, that they should tell. And they keep adding conditions to that list, and I think right now they're up to about 25. So it might be that we all will eventually have to think about how much do we want to know, even if we don't go out to take that test ourselves, that you will run across it in some way or another. So the other, of course, this will come as no surprise, is pharmaceutical companies are very interested in your DNA, and right now they're finding lots of creative ways to tap into that, partnering with companies like 23andMe. So you're taking an ancestry test, or you're doing something else, but pharma companies are able to have a look at your DNA. And this is very important to them because, as we all know very clearly now, not all drugs are for everyone. And so they are going to start developing treatments to match your genetic code. But in the meantime, and this is a bit of a controversy, of course, in the meantime, they have in a few cases tried to use race as a proxy. So there was a few years ago, I don't know if you might recall this, but they came up with a drug called Bidil, which was billed as the first sort of race-specific drug. It was a heart drug for African Americans. And yet the genetic underpinnings for why that might be the case, or the idea that there couldn't be white people walking around with sort of the same sort of biological rationale for having that, or black people who didn't have that, didn't come into play. And ultimately it met with a whole lot of controversy. So the big business, I put it all together under sort of marketers, because there's just so many commercial interests now in having human DNA. So this, a few years ago when I was looking into this, Visa, for example, had just filed a patent application to come up, or basically they had designed a search engine that would allow them to look through the databases for genetic information. And then there were privacy concerns, and they withdrew that application. But one of the big issues around this, of course, is the direct-to-consumer testing market, because as DNA sequencing costs have dropped and people are interested in the information, companies have sprung up, many of them not regulated. Then there's ancestry companies, which I'll talk about in a minute. But of course now too is the very real issue of, my gosh, what are we going to do with all of this information? If each one of us in this room had our DNA sequenced today, we could wrap it around the world many times over, and I'm pretty sure it would slow your computer systems down. So Amazon and Google have, both very much jumped into sort of the data storage of genomic information, and major institutions, for example, like the Broad Institute that I mentioned earlier, have partnered with these guys to store DNA in the cloud. Well, what happens to that information? I mean, we've lived through the era of seeing, celebrity photos pinched off their cell phones that were in the cloud, and so on and so forth. Who has access to that? What might happen to that information? All of that is a very big question mark. But at the moment, not being able to store it somewhere could literally slow down the pace of science. I'm going to jump ahead only because I'm fearing a little bit that I might run out of time. But the police and law enforcement people, as I mentioned early on, have always been very interested in DNA. And they are getting very creative as well in ways of sort of taking DNA from a crime scene and now being able to compare it with familial DNA. So there's now many cases in which rapists and serial killers and cold cases have been solved because police have been able to go into DNA databases, DNA that might have been collected for some other reason. In one case, collected in a blood sample from the heel of a boy who grew up to be a killer, but whose DNA was kept on file as part of this blood test. In another case, the criminal's sister had joined an ancestry testing project, and the common genetic traits identified in that woman's DNA led police to her to ask if she knew anybody who might be involved in such a thing, and it turned out she had an estranged brother. So there are creative ways that are happening. So on one hand, if great news for crime and justice, or is it? People who are proponents of civil liberties would say, gee, you join these projects, you think it's all kind of fun and recreational, and next thing you know, you're involved in something much more serious than you had ever imagined. And now this is the one of all of these groups, I think, that in Canada we have to really talk through in a more urgent and direct way, and that is employers and insurance. It's possible to look for, especially during this time of this kind of foggy period of uncertainty with understanding what genetic traits mean, but entirely possible that an insurance company might deny you coverage or raise your premiums if they think you have a condition that could put you at a higher risk of requiring medical treatment or your ability to work. Employers, especially employers who are looking for to fill top jobs, they already do intense sort of 360 style interviews to find out about you and whether or not you have the psychological chops to deal with the stresses that are going to come with the job. So let's say you have candidate A and B, and they are on paper both equal, except candidate B looks like he has a very high risk of being an alcoholic, or he's prone to depression. Well, I think I would like to choose candidate A. So we have nothing at the moment really to prevent that kind of thing from happening. We don't have a genetic non-discrimination law on the books in Canada, and we are the only G8 country that does not. So these are the kinds of conversations I think that the pace of genetic medicine is going to put to the forefront. And finally, there's a whole issue around DNA and families. There have been policies, drafted by various genetics bodies beseeching parents not to test their children for fear that they will overinterpret results and take what they see there and decide, this was actually chronicled in a case in Australia, and a few cases in Australia where, well-meaning parents were having their kids tested for, various genes related to their athletic abilities, and based on whether or not they had fast twitch or slow twitch muscle fibers, were deciding if their kids should be sprinters or marathon runners, or what sports they should put them into. And there's a danger there that you try to do, you think you're trying to do good things for your kids. You want to know about conditions that you might be able to prevent or alleviate. But is there also a danger that you will then put your kid in a box, basically, and think of your child differently, not just as having the full scope of the world, basically, to explore and to pursue. And it's this idea that again, that genes are your destiny, when in fact they are not. What they are, in fact, is sort of a backdrop for certain things. But there. In fact, Steve shares a good example of this. Is that I did a story once about how he found out about particular traits that he has that allow him to basically have a high metabolism that keep him very thin. It would always drive me crazy whenever I'd see him. He was like drinking Coke and eating donuts and like fettuccine Alfredo, and the guy looks like this. And the only exercise he does is driving, his son to hockey, he said. And I said, is that fair? But, does it mean that if you don't have those genes, you also couldn't, not be overweight? No, it means, unfortunately, you have to work way harder at it. And so I think that there's a certain amount of uncertainty just in terms of human will and the ability for, the human spirit to transcend or to override, put it in whatever terms that you want, but that a certain amount of self-determination, I think, can outweigh whatever, particular traits, not all, but many of the traits that we might be inclined to take as deterministic. And finally on that point about whether or not you want to look into your own story and sort of open that box, that Pandora's box, and this is a very important thing to remember, and certainly something that came up for people in the Personal Genome Project, is that it's not just your story. You share your DNA with your family members, parts of it, and no one takes a DNA test in a vacuum. Even Michael Zago, who was the ethicist on the Personal Genome Project, was unsure until the very last moment whether or not he wanted to participate. Now, granted, he had really been exploring all of the possibilities of things that could go wrong if you gave up your DNA, including the idea that somebody could make a synthetic copy of your DNA and plant it at a crime scene, which actually was at the in the final informed consent. But he was worried about his kids. What if they find something? So I might be okay with employers knowing this, or figure out my way through the insurance quagmire should that come up. But would my kids be able to? How would it affect their future? And again, so this was something that I learned firsthand. And I'm just going to go forward once. So going back to that time, time of SARS in 2003, when I had my first child, it happened to be in a hospital under quarantine. It was in lockdown that my daughter was born, and nobody could come to visit us in this hospital because SARS had restricted all visitation, and there we were, my husband and I and our new baby, in this dark corridor lockdown hospital room, and all we could do was answer the phone. And this was actually not that long ago, but we didn't have digital cameras, so there was no photo sharing and that sort of thing. But everybody was calling, and everybody was asking the same question, and that question was, well, who does she look like? What does she look like? She look like you? She look like Steven? She look and you realize what people are really asking is, so what elements of DNA have actually popped out in this new life? And because I had a lot of time on my hands at that moment, I started to think about what I could see, and about the questions that I got growing up about where was I from, what was my background. We had grown up, or I had grown up for a while in a small sort of whitish town, I guess I would call it, and we were sort of brownish people, and I had a Jewish last name, and I went to the Catholic school, so I got the "what are you" question all the time. And I would go home and I would ask my parents, well, what are we? And the answer was always extremely long and very complicated, that, we were a little bit Portuguese, and we were a little bit Dutch, and we were a little bit English, and probably some Scottish, and maybe some Irish, possibly a little Indian, but nobody knew for sure. It was long, it was complicated, and it was terribly unsatisfying. And then when I was 10, I met my grandfather, my paternal grandfather, for the first time, and it turned out that he looked Chinese. And I was utterly gobsmacked. And I just thought, okay, now this is ridiculous. And I remember pressing my parents with many questions over the years. And in the meantime, I think, what many of us do, and that was I just made up my story. I just said, oh yes, I'd heard he was a juggler, which I had heard. He was a Chinese juggler who had appeared in South India and disappeared, and somebody gave him the name Abraham, and nobody knew where he came from, and nobody knew where he went. But I would often get, and I still get asked, cab drivers, everybody, oh, are you Lebanese? Oh, are you Greek? Oh, so I would pull out my Chinese juggling grandfather and turn him into this sort of iconic figure. He was so famous. He was like a juggler with the Chinese National Circus, and he defected, and he was this and he was that. It was all garbage. I didn't, but you know, it was just a story because there was no other information forthcoming. So I thought, you know, my daughter is going to grow up. She's going to ask those same questions. And now the cost of testing DNA has dropped into the affordable range. So I'm going to take a look and see if I can actually solve this mystery of my Chinese great-grandfather with the genes that they left behind, because we, all of us, are compilations of all the genes and chromosomes of the ancestors who came before us. So my mother, and I've put this picture in the slide because my mother was like not very enthusiastic about participating. My father was very gung-ho. He said, I would love to know whether or not we really are Chinese. I really want to find that story out. And my father's an engineer, so he has a certain amount of respect, shall we say, for the idea that science will, you know, do what folklore never could, which is, you know, provide the solid answers. And my mother, you know, she's not one to really look back. She's a very forward-looking person. So this was taken on holiday in India in 1971. So I put that picture in there because this was how she felt, how she generally feels about most things in life. But interestingly, when it came to DNA, she felt completely the opposite of this. We talked for about 2 years about the possibility of me doing this project. And my mom's ultimate condition was, I will let you test my DNA, but you will not be able to use my DNA to look forward. There will be no looking for conditions we might have or things that might befall us. We will only look for things that are involved with our past history. And as it happens, it's entirely possible to do that. Sometimes things might slip out, but generally speaking, and this is a bit of a simplification, but it is, I would say, much easier to use DNA as a portal to the past right now than it is as a crystal ball to look into the future. Because in trying to figure out where you came from or who else you might be related to, the object of, or the goal of what you're trying to figure out is basically how much does your DNA look like somebody else's DNA? How much does it resemble the mutations in this part of the world or in this part of the world? And it's not about what those mutations mean or don't mean. It's just, do you see them? Are they in common? So that was exactly how I set about to do this. And there's, I won't go into a lot of detail about how I did it, but what I wanted to bring up in the course of talking about the exercise of this was that I confronted something, well, a few things. It actually thrust me into way more ethical minefields than I had imagined at the outset. First of all, I thought, well, we'll just do some tests, we'll get the answers, and I'll write the book. So 10 years later, not the way that it went. First of all, the data banks grew and grew and grew, which helped considerably. So the more people that you have to compare your DNA with, the more likely you are to find answers to the questions that you're looking for. At least DNA, from the perspective of your ancestry, it's going to be able to tell you the where, a little bit about the when, but it will never tell you the how or the why. So that's the kind of stuff you have to get from, you know, talking to your relatives, having big cups and pots of tea with your family members to find out the hows and the whys of how people came and went and why they did and so on. But what DNA can do, and I think this is something that increasingly ancestry testing, which has really been growing in leaps and bounds, is that it can really challenge and conflict with your notions of self. So by that I mean, my father, for example, was really excited to learn that the possibility was there that he would find out from his DNA whether or not his father and his father's father really had come from China. And DNA was able to tell us that. But I compare this to, say, my husband, who is actually from Alberta. And he looks like, if you saw him, he looks for all intents and purposes like, you know, a tall Viking type, like sort of Scandinavian, blonde, blue-eyed, but he had always walked around with this sense that he was 1/16 Cherokee, because his family came over from Europe and they homesteaded in the West, and there was a branch of the family that went down to Missouri, and you know, they were just a few miles from Jesse James, and you know, there's a lot of story around this. And you know, we'd go out in the sun and he'd lift up his arm, I'm darker than you, Abraham. And because he's 1/16 Cherokee, because that's what had been passed down. And then the first DNA test that we do, looking for this kind of thing, the result comes back, and this was early days. The result comes back and it says 100% European. He was bummed out. It was like he'd lost something. You know, it made him question a whole bunch about, oh, I wonder if it was true. You know, and I raised the point, and I still think it's a valid one, that, you know, maybe there are ancestral markers that might link you to that population. It's a huge code. This only tested a few of them. But the point is that, you know, there is a risk there, that what you find in your DNA does not coincide with what you think of yourself and your family story. And there are now some really famous examples of that. In fact, in my book, I cite a couple of my favorites. There's a man in Yorkshire who, again, looks like, for all intents and purposes, to be, you know, a good Yorkshire guy, bowls at the local bowling alley and so on, and he participated in a research project that actually discovered he has one of the most rarest types of African Y chromosomes, so male, African male lineage of his forefathers that they had rarely seen outside of Africa before. And this became, you know, huge, a huge story, right, in the local papers there. And his wife was puzzled and said, you know, he never asks me to cook anything unusual. He, you know, he's always looking for roast beef on Sundays and that sort of thing. And the same thing happened when they have discovered, you know, a very strong genetic link or a genetic origin for a lot of the people of Ireland. You know, I think we've all heard of the dark Irish, you know, Irish people who have very dark hair and lighter eyes and so on. And where did that come from? And there have been different stories. And you know, the genetic puzzle looks so far like these people are descended from, you know, Fertile Crescent, sort of Turkish area farmers who came north and brought farming with them. And so it was really suggesting that, that, you know, there is a much closer relationship between, you know, the Turks and the Irish. And so, of course, how did this play out in the Irish newspapers? It became, you know, okay, let's all go down to the pubs in our fezzes and raise a pint. And there's lots of talk about like how you could now, you know, sort of draw their culture into your own. And I think that that's where DNA is very interesting, is it introduces new elements of ourselves into our story. So and of course there's not always, you know, not all of this is funny. There's the sense, of course, too, that for African American populations this has been a difficult thing to swallow, because as they've discovered in the United States, about a third of African American men actually carry the Y chromosome, the male chromosome of a white forefather, which is, you know, harkens back to the politics of slavery. And again, as well, the other thing that genetic testing, and I discovered both of these things, I ran across them in my own family research, is that, you know, 10% of us, the number varies depending on which genetic scientist you're talking to, are not fathered by the man we think of as dad. And that's a big number in terms of family trees, because it snaps whole branches off those trees. So there's another thing that's happening there too, and that is that we are being forced to consider the way we view our relationships with each other. I dealt with this a little bit in my book, but you know, who is dad? And the courts have decided it doesn't matter what your DNA says. If you have grown up with this person as your father and you consider him your dad, he is your father in all the ways that truly matter. And so there's the cultural, there's the biological relationships and things like that. But one thing I would say, and I think this holds true, is that no matter what information that you're talking about that will flow out of your genome, it only has the power that you give it to inform the way that you react. And on that note, I would just like to say, you know, there's exciting things coming in the future. I think that the possibilities of personalized medicine are exciting. They could very much, you know, change the way that we live and the way that we actually treat ourselves and our healthcare system treats us. And there's big questions coming too. You know, right now in Baltimore, the scientists at the American Human Genetics Society are debating things like whether or not these new these brand new tools to edit the genome, with incredible precision and ease should be used, or should they not be used to edit egg and sperm cells, so that the possibility of ridding our species of certain diseases, it's not fictional, it's a possibility. It's in fact, a few years ago, NASA was asked, of all of the science fiction films that exist, that are around, which ones would you say are most plausible? And they said, I think it was their #1 pick was Gattaca. I don't know if any of you have seen Gattaca, but it was the idea that we would move towards making all babies in a lab, because we could just alleviate so much suffering and disease from the world. But the problem that, of course, emerges in Gattaca is that the natural born sort of live in the shadow of the lab-made babies. And what started out as a bid for improving our health became a bid for enhancement. So we are very much in the midst of terra incognito. And I thank you very much for having the opportunity to come out and speak about these issues. Because as a society and as individuals, I think we're going to be confronting them sooner rather than later. Thank you very much.
Thank you for that, Carolyn. That certainly, you said, yeah, the genetics is interesting. I agree. It's also much more complicated than I certainly realized beforehand, and a little ominous. At this point, we do have, they're directing me to go to the mic. Thank you, Jason. Okay, at this point, we do have some time for questions. And what I'm going to ask you to do is to please, if you have a question, come up to the mic that's right there in the aisle. If you can't come up to the mic, then let me know and we will bring this one to you. So.
Hi, Carolyn. Thanks very much. My name is Jem Kane, and I read your book, The Juggler's Children, and what I wondered was you were trying to identify the region or area or village in China that his father might have come from.
Right.
Were you ever able to do that?
No, not to the village, but to the region. I think is a possibility that I'm still investigating.
Is your dad still alive?
He is. He just turned 90.
That's wonderful, because I know he was really keen on finding what part of China he came from.
Yeah.
My other question is, are you ever going to make your Einstein book available in ebook, because it's out of print?
Yes, I'm working on that.
Oh, okay, so I'll keep looking for it.
Oh, thank you. Yeah.
Another quick question,
yeah.
when you were talking about paternity,
Yeah.
what do they do when they do genetic testing on a child and on the parents and discover that the father is not the actual biological father? Do they tell them?
Actually, so this is something that Sick Kids has dealt, Toronto Hospital for Sick Children has dealt with often, many times over the years, and in fact it's where I first heard the statistic of 10%, and they consulted lawyers and ethicists, and unless it's changed, the viewpoint was that the information that's handed out should always be given in the best interests of the child. So they have decided not to tell.
Okay. Okay, well, thank you. I really enjoyed it today.
Thank you.
Do we have any other questions?
No?
Hi.
Hi.
So my question is, what's the process of giving your genetics to be tested and figure out all that?
There's different ways you can do it, and it depends who's doing the testing. So my experience has been that if you're working with a hospital lab or a university research project, they will take a blood test. Mm-hmm. If you are working with a direct-to-consumer testing company, they might ask you to do a cheek swab. vigorously rub the inside of your cheek for 30 seconds. I discovered there's no graceful way to give DNA, or spit into a small vial, which is also not fun. So there's those are sort of the typical tests that you will see. Sort of private companies will offer, but often, especially if you're working with somebody locally, they'll want blood.
Okay, but like if I wanted to, where would I go?
Oh, you're asking, so who would, I think it depends on what kind of testing that you're after, and what you're looking for. And I actually think that's a really good starting place for anyone who is thinking about getting genetic testing is, why do you want to do it? Why do you want to do it? And then if once you decide that, so if you're deciding that this is a whole genome sequencing project that you're after, you might decide, for example, if you are comfortable with making your information, and it's not your name, but it is your personal medical information and your genome public, you might choose to sign up with the Personal Genome Project, or you might choose to go with a particular genetic testing company, and I wouldn't actually recommend one or the other. I wouldn't recommend a private company per se to do that. I think I'd leave that for you to research yourself, depending on what you're after. And if you're doing ancestry testing, the one thing I would say, and this informed my decision about who I tested with, I joined a few research projects, but I also tested with a private company, was that for me, because I knew that most of the people I wanted to compare our DNA with weren't going to be Western Europeans, I needed to find a DNA database that had huge sort of international representation, or as big a database as I could find. So that's actually sort of one thing you might consider too. So it depends. Are you looking for medical reasons? Are you looking for ancestral reasons?
Okay. All right. Thank you.
No problem.
Hi, one quick question. I heard about a project which I believe was cheek swab testing that was done with National Geographic and the Smithsonian Institute. How does that compare with what you've just talked about? I think it was migration patterns that they were looking for there.
Right. So yes, I was actually in the middle of starting my project when IBM and National Geographic joined forces and said they were going to do this sort of genetic history of the world, and it was a real terrific boon for me, because suddenly the available database of samples went from a few thousand to about 100,000. It seemed like in a very short period of time. So once you get your results back, those tests are looking at very specific things. They're looking at telling you sort of where in the world your ancestors came from. So what was their migratory route out of Africa, basically. And once you have that information, though, you are then free to upload it to various other sites where you can then compare your results with people who have tested with other companies in other places, and possibly find out things. So just very briefly, I mean, the Y chromosome, which only males carry, and men inherit from their fathers in this sort of unbroken chain from fathers to sons, is really the most powerful tool to investigate ancestry, because most surnames have been passed down patrilineally, and so if you find a Y chromosome that matches your Y chromosome, you can actually oftentimes find a common name that your forefathers shared. Probably the most astounding example of this was the 15-year-old in the UK who had been conceived by a sperm donor who took a genetic test, and through nothing more than a cheek swab and the internet was able to find his sperm donor father.
Okay, well, looks like those were very good questions, and it looks like it's now time for us to start the reception. Everybody is invited to stay and join in some sandwiches and vegetables, and you might want to ask Ms. Abraham some questions, one-on-one at that time. So before we do move over to the reception, I would just like everyone to join me in, again, thanking Ms. Abraham for quite a compelling and interesting talk.
Thank you. Thanks, Melanie.
Oh, it worked fine.